Today our experiment is the VI characteristics of junction field effect transistor. So for this experiment the components are breadboard, the FET, the main component is the FET, field effect transistor. So it has 3 terminal. So this is notch. So left of the notch is source, then drain, then gate, anti-clockwise, SDG. So left of the source is, left of the notch is source, then drain, then gate, SDG, right? And 1K resistor and 10K resistor, and the connecting wire and the voltmeter and also the ammeter. So here the notch is available, okay, and the left of the notch, that is source, drain and gate, and there is another terminal that is called substrate that is not used in our circuit. So we put the FET just like this way, the source in this side and then drain and then gate in 3 different holes which are not connected, okay. Then we put the 10K resistor, this is the 10K resistor, to the drain terminal, maintaining some distance. So this side the drain terminal is situated, that's why we connect any of the hole this resistor, okay. And between the drain and the resistor terminal we put the ammeter, okay. That's why we keep some space for the ammeter. Now the circuit is connected to the power supply. This is the DC power supply, okay, and from here we take just plus 15 volt and the common or the respective ground or 0 volt. This is the respective ground or 0 volt of this voltage, okay. So this voltage you connected to the source terminal because this is common source configuration circuit, that's why the source is ground here. So we connect the power supply ground to the source, then we connect the ammeter. This is our ammeter. So this ammeter is connected between the drain and the resistor, okay. This is the 1K resistor. So you just connect the ammeter between the drain terminal and the resistor, and the rest terminal of the resistor is connected to the positive voltage, okay. And this, now we take reading for VGS equal to 0. That's why we short the gate terminal and source terminal with a wire, okay. Hence the source is grounded. So if you connect it or short the source terminal with the gate terminal, that time the VGS is 0, voltage drop across the gate and source is 0. So now we take reading for VGS equal to 0. So now our VDD, then that means drain supply, is 1 volt, and our VDS, the voltage drop across the drain and source, is 0.74, and our ID is now drain current, ID is now 0.43. And now our VDD is 2 volt and the corresponding VDS is 0.79 and the corresponding ID is 1.37. And now our VDD is 3 volt and the corresponding VDS is 0.81 and corresponding ID is 2.38. And now our VDD is 4 volt and our corresponding VDS is 0.83 and ID is 3.32 milliampere. Now our VDD is 5 volt and the corresponding VDS is 0.84 and ID will be 4.34. Now VDD is 6 volt and corresponding VDS is 0.85 volt and ID is 5.34 milliampere. Now it is 7.1 volt and the corresponding VDS is 0.86 and ID is 6.47. Now it is 8.3 and the corresponding VDS is 0.87 and ID is 7.70. And now the VDD is 9 volt and the corresponding VDS is 0.87 and the ID is 8.45. And now the VDD is 10 volt and the corresponding VDS is 0.88 and the ID is 9.49.